Hello, we are discussing about GATE 2009. Look at the circuit diagram. The switch in the circuit was on position A for a long time and it has moved to position B at t is equal to 0. Find the value of current I of t for t greater than 0. What is the expression for the current I of t for t greater than 0 that we are going to calculate? Okay, so there are three capacitors are connected as shown. So you can remove all these three capacitors and this combination is replacing with a single capacitance value, which I am saying it as C equivalent. Okay, C equivalent can be written as these two are in parallel, so they will be get added, so that 0.5 plus 0.3 microfarad capacitors in parallel with 0.2 microfarad, because 0.2 is in series with this parallel combination. So this you can write, and finally you can write it as 0.8 in parallel with 0.2 microfarad. That you are going to make it as, this is the value of this one is 0.16 microfarad. The effective capacitance of the capacitor circuit shown is 0.16 microfarad. Now let us assume the switch is not closed. So for t less than 0 minus, because at t is equal to 0 switch is moved to position B, so that we are assuming that the switch is still at position A. Before t is equal to 0, for a long time it is at position A. Since the switch is connected to a position A long time, circuit reaches steady state. Okay, for a long time, whenever for a long time capacitor reaches steady state and it has stored the maximum value, reaches steady state, and in steady state, okay, capacitor, that is C equivalent, acts as open circuit. When it is acting as open circuit, then the circuit is going to be looks like this way. Okay, so this is open circuit with 100 volts battery connected to this combination, and the voltage across this one is nothing but Vc of t for t less than 0 minus. So at 0 minus, final value you can say it as plus minus, because current is flows in this direction whenever 100 volts is connected, so that it charges plus minus. Okay, current is entering into this terminal, so that this terminal will become positively charged. Vc of 0 minus will be equal to same voltage as 100 volts, because there is no voltage drop across this resistor as it is acting as open circuit. In open circuit we know no current flows. Okay, so voltage across capacitor at t is equal to 0 minus is 100 volts. So capacitor has fully charged to the final value, that is what the voltage connected to that capacitor. Now for t greater than 0, capacitor combination is now looking like this way. This is capacitor and it is now connecting with a resistor. So previously it was with a voltage of 100 volts. Okay, so initial voltage of this capacitor whenever the switch is turned to position B is 100 volts, and this is C equivalent. This is R 5 kilo ohms. Now whenever it is connected to B, a current flows, that is I of t. We are going to find this I of t, and capacitor now is discharging the voltage stored across it. Previously it has charged because 100 volts is supplied. Now it has stored some voltage, that is what initial voltage. Now it will be coming into steady state by discharging it. Okay, now capacitor voltage discharges. As the capacitor voltage discharges, current flowing through this resistor, that is I of t, is also reduces. Okay, and if you are able to write the expression for voltage across this resistor R, voltage across this resistor R can be written as I of t into R. But voltage across this resistor is same as voltage across this capacitor because both are in parallel. So you can write the same expression as Vc of t. So that means I of t is proportional to Vc of t. Capacitor voltage is directly proportional to I of t. If capacitor voltage is reducing exponentially with some time constant tau, then I of t also reduces with the same time constant tau. Okay, if the capacitor voltage reduces exponentially with time constant tau, then current flowing through this circuit, that is the resistor and capacitor combination, this also reduces by the same time constant. Now, if either current or voltage, if it is either increasing exponentially or it may be decreasing exponentially, you can calculate that value at any point of time. You can calculate the value of the exponential waveform at any point of time. At any point of time by going through this equation. That equation I am writing with respect to current, but that can be written with respect to voltage also. I of t is equal to final value of current plus initial value of current minus final value of current into e power minus t by tau. Tau is the time constant of the circuit. Now where tau is equal to, for this circuit, tau is equal to R into C equivalent. R means 5 kilo ohms because now the current is flowing through this 5 kilo ohms. So 5 into 10 power plus 3 into C equivalent is 0.16 microfarad. 0.16 microfarad means 10 power minus 6. So this tau value is equal to 0.8 milliseconds. It is turning towards 0.8 milliseconds, that is 0.8 into 10 power minus 3 seconds. Now we need to find I infinity and I of 0. I of 0 is nothing but initial current, that is I of t at t is equal to 0. So simply I of t can be calculated by using this equation. Okay, so from this one, Vc of t is equal to I of t into R. At t is equal to 0 plus, replace t with 0 plus. Then I of t is equal to I of 0, that is means by Vc of 0 divided by R. Okay, Vc of 0 is capacitor voltage at 0. And remember that one, voltage across capacitor doesn't change instantaneously. So voltage across capacitor at 0 minus and 0 plus. That is before t is equal to 0 and just after t is equal to 0. 0 minus means just before t is equal to 0. 0 plus means just after t is equal to 0. And both will be same because capacitor doesn't allow instantaneous changes in the voltage across it. So this already we have seen Vc of 0 is 100 volts. So 100 divided by R. R value is 5K. So I of 0 is equal to 20 milliamperes. Next, I of infinity. I of infinity is current I of t at t is equal to infinity. At t is equal to infinity is you have gone with this circuit for a longer time, infinite amount of time. By that time again capacitor reaches steady state. Again capacitor reaches steady state. Whenever capacitor reaches steady state, it acts as open circuit. Now the circuit is going to be looking like this way. And there is no voltage present. All the voltage is going to be discharged. Okay, as you are giving much time, capacitor discharges entirely. So that now 0 volts is going to be presented across capacitor. Okay, 0 volts is present means no current is flowing through this circuit. Otherwise you can also assume in this way. Under steady state capacitor reaches, capacitor acts as open circuit. Whenever it is acting as open circuit, as there is no other voltage source present for this circuit, current flowing through it is 0. So I of infinity is equal to 0. So now we know I of 0, we know I of I of infinity, I of 0 and tau also. Simply substitute these values. Okay, so I of t is equal to I of infinity, which is 0, plus I of 0, which is 20 milliamperes, minus I of infinity, okay, 0 into e power minus t by tau. Tau means 0.8 into 10 power minus 3. This 10 power minus 3, if it is going 10 power plus 3, that is 1000 by 0.8, that will become 1250. So this is 20 into e power minus 1250 t milliamperes. This is a current expression I of t. 20 into e power minus 1250 into t. So the right answer for this question is this one, 20 into e power minus 1250 into u of t. Okay, why this is u of t? You may be getting confused. Okay, u of t is nothing but unit step function which starts from t is equal to 0, and this current is also starting from t is equal to 0. At t is equal to 0, 20 milliamperes. Okay, and before t is equal to 0, no current, because this resistor is not connecting with the voltage before t is equal to 0. Okay, that's why it is given as u of t. So the right answer for this question is B. Thank you.